In this video, I'm going to build a low-power FM stereo transmitter that was sent to me from the folks at icstation.com. This is a low-power phase lock loop stereo transmitter that you set the frequencies with dip switches. Let's get building. Let's build a kit tonight. Let's build a kit night. I just got this little package in from China. And it's a bag full of parts. And a little circuit board. And what this one here is, we've seen this before. If we look closely at it, this is using a BH1417F. I think you guys know what used that IC. This is the stereo FM transmitter board kit that I was telling you that I was getting. It's from EEQ Kit, and this thing here is probably going to be more to the liking of what I need for testing. Now this one here doesn't use an Atmel to set the frequency. It's done by setting dip switches. So you can pick one of several frequencies for this. And what we've received is just a bag of parts. And as you can see, the silk screening here tells us what parts to put in to what places. So the first part we're going to install is going to be the surface mounted part, just because that's going to be the most difficult one to install. And it's the only, I think it's the only surface mounted part on this. So we'll do that one first, and then I'll start mounting the other components on here. So here's our IC. This is the one I'm probably going to need the most amount of help on, either by using my microscope here to inspect it, or my magnifiers, which I'll use to actually complete it. So let's get the IC in place, and we'll tack this one down. We'll start out with this IC and then start mounting the other parts. This will hold the IC in place so that I can do the rest of them. Okay, now we'll tack down the rest of these terminals. We've got some 10K resistors to go in here. So that's brown, black, orange. So we've got 1, 2, 3, 4, looks like 5 of them. So 5 of them. There's 5 10K resistors right here. Nice thing about this kit is they're using the standard, not using precision resistors, so they've only got the 4 bands instead of the 5. So it makes it really easy to figure out the color codes, especially for someone like me that's old school. When I was in the business, there was no 5-banded resistors, there was no precision resistors. All we had was the standard color codes. So it was easy. You didn't have to think about that third color and then the multiplier being 1 down, right? Of course, on a precision resistor, on these resistors, it's brown, black, orange. On a precision resistor, it would be brown, black, black, red, and then followed by the last band, which is usually brown on them for 1%. This one here, the last band is gold. So there's our 4 or 5 10K resistors. That we'll solder those down. continuing with the 10K, we get all the 10K resistors mounted first. There's two more, no, there's one here. 10K and a 10K, there's two more of them here, three more of them. So let's get those three mounted. So now we'll start the ceramic caps. They're marked on the board. C5, it's a 104, so 104 picofarad, so it'll say 104 on it. C3 is a 30 pico, so it'll have a little 30 marked on here. These ones all have markings on them. There's a 30 there. These ones, the polarity is not important, but it is important to get them low on the board. Okay, that's it for the ceramics. Let's do the electrolytics now. What do we got here? 1 microfarads. There's a 1 mic there. These are polarized, these ones, so you gotta watch the polarity. It's a 1 and another 1 here. And 2 10s. There's a 10. There should be another 1 and another 10. There's another 1 there. Actually, there should be another 1 as well, and a 10. This one is a 1. So that goes in here. There should be 1 more 10, wherever it is, over here. Oh, that's a 47. Another 10 is, I think this is a 10 here. That's a 22. What is this one? Another 1. And yeah, some coils to mount. A couple different coils. Actually, there's 3. There's this one inductor. Where does it go? It's a 1500 microhenry. That's this one here. Or sorry, 150 microhenry. Brown, green, brown. That goes right here. There's 2 other coils here that have to go in. I have to figure out where they go. L2 and 8 turns and 5 turns, it looks like. Okay, so that's 1, 2, 3, 4. That's a 5-turn coil here. And that would mean that this other one, which has got 8 turns on it, goes into this one here, L2, which says 8T for 8 turns. They've actually done a very good job on making this kit as easy to put together as, I mean, this is really simple. Hardest part to put on this kit was that SMD. If you can handle one SMD part, then you can handle this kit no problem. I should point out that if you're seeing the short version of this video, then you're not a patron. If I'm doing 2 versions of this. The condensed version is the public release, and there will be a full non edited Patreon release also showing the placement of every component and all the testing and everything. I try to keep these videos relatively short because this is being done more as a promo for the for IC Station, but there will be a full released video of the same assembly, but like I did with the AM transmitter build, it'll be for patrons only, and it'll show the placement of every part, and nothing will be skipped, nothing will be cut out. So we've got a couple transistors now I've got to mount. It's got a 9014. What's the number on this one? That's a 9018. Where's that one go? 9018, here it is. 9018 goes here. Okay, this one here is the FE1043. It's the variable diode, it's a voltage variable diode, and it goes down here. This is this one. Numbers are very hard to read. I had to use my microscope for that. And then the Zener diode is this other one over here. And baby goes in there. This is the switch between, I believe, the low and the high end of the band, because it can either work on the 88 or the 108 side. There's only so many frequencies you can set with the 4 dip switches. I think it's got 4 dip switches. Yeah. So there's only so many channels you can set. You either pick them on the low end of the band or the high end of the band. This is the switch that selects which side of the band you're going to be on. Here. The first transmitters I built, the ones that went into commercial service, they all were set with dip switches. Because typically, you know, once you're set, you don't ever have to change it. You shouldn't anyway. Installed the correct way, not like the other one where they bridged over the audio switched line, which of course made everything go to mono. We won't make that mistake on this one. Not much of an antenna. It will do for this testing, for sure. Antenna just goes over here. And we have our battery case, or we can run it with power supply. I'll just test it with batteries because I've got them here. Got the battery case here ready to go. Okay, I've got it, all the switches are set low. That should be 87.7. I've got my radio tuned to 87.7. We'll just load up some batteries here. And watch it not work. Well, the light lights up. Do we have any signal? I don't hear any signal. Ah, that's it. So they're opposite. Switches on to create low, off to create high. I've got my signal. Sounds nice and quiet. Let's see if it'll play music. I'm probably over-modulating here. I'll have to adjust the levels, but maybe not. Go. Doesn't sound bad. It's full stereo. The schematic here too, so it probably wouldn't be hard to increase the power on this thing. Let's see, S3. What's that doing? Okay, that's this one here. That'll change the band. Yeah, that changes the band. So there it is, it's complete. As you can hear, it's pretty quiet now. I've got my other one still turned on. I plugged it back in. If I tune the radio down to 87.5, you'll hear my other one. And then this one. Running the same music. Anyway, that's it. It's all done. That's the little FM stereo transmitter kit from IC Station. Links on the page here. If you want one of these things, they're pretty inexpensive, fun to build, doesn't take long, and you know what? It works. We'll catch you later.